This is section 7.3 of chapter 7. Double angle, half angle, and product to sum, and actually sum to product formulas as well. So we start off with double angle formulas. Those two are on the deck, so memorize them. There are 3 for cosine. You get to choose whichever one you want to use. Usually from whatever's given there's a better choice of whatever formula to use. So we're going to start with example. First example, we have cosine x is -6/11. X is in quad 2, and we want to find sine x and cosine 2, or sine 2x and cosine 2x. So actually I'm going to draw a right triangle. In my right triangle, if this is x, like our angle, and cosine is adjacent over hypotenuse, then the adjacent side is 6, the hypotenuse is 11. To figure out any third side of a right triangle, you use Pythagorean theorem. And I'm subtracting actually because I have the hypotenuse and I have a leg. I need the other leg. So this ends up being the square root of 85. Sine 2x is equal to 2 sine x cosine x. So 2. In quad 2, sine is positive, so I'm good with that. Using my right triangle, sine is opposite over hypotenuse, so square root of 85 over 11. And cosine x actually gave us in the actual problem, which is -6/11. And using some wonderful math, our answer is -12 square root 85 over 121. If you can reduce, reduce, but this one cannot. Cosine 2x. Now I can choose any one of the formulas up above, but I'm going to choose the third one because 6/11 is a nicer fraction than anything with a square root of 85 in it. So cosine 2x is equal to 2 cosine squared x minus 1. So we put our 2 down, -6/11 for our cosine x. We're squaring it, minus 1. Well, -6/11 squared is 36 over 121. 36 times 2 is 7. 36 times 2 is 72. That's negative. Oh, no, it's not. It's positive. Just kidding. It's positive because I squared it. Minus 1. And we end up getting -49 over 121. The triple angle formula. Why not? We'll do it. Why not? That is equal to cosine of 2 theta plus theta, right? To get 3 theta, which is actually a sum formula from the previous section. So cosine 2 theta cosine theta minus sine 2 theta sine theta. Cosine 2 theta, I'm going to choose the same one as last one because we want in terms of cosine only. So I'm going to change cosine 2 theta to 2 cosine squared theta minus 1. And that's all being multiplied by cosine theta. And sine 2 theta is 2 sine theta cosine theta times sine theta. That's a sine there. So I'm going to factor in my cosine theta. So 2 cosine cubed theta minus cosine theta. And then here I'm going to multiply my sines together. So minus 2 sine squared theta cosine theta. Well, sine squared theta can be changed to a cosine. That's the trig identity one. Recopy everything in the front. So 1 minus sine squared theta turns into 1 minus, or sine squared theta turns into 1 minus cosine squared theta. We have a cosine theta at the end. So I'm going to factor in now, leave the first 2 terms, I'm going to factor in 2 cosine theta into the parentheses. So -2 times 1 is -2 times cosine, -2 cosine theta. Negative 2 times negative cosine is positive 2 cosine squared times cosine squared. So plus 2 cosine squared theta. Cubed. The cubed theta. Cubed. At the cube there. I just combine like terms. So we have cosine cubes, which are 4 cosine cubed theta. And then cosine theta, which is minus 3 cosine theta. And there you have it. Got all that down? If not, pause, rewind, whatever you got to do to get that down, because I have to erase it now. All right, proving the identity. Cosine 2x. I'm going to change that to cosine 2 cosine squared x minus 1, and there's a plus 1 from the numerator, over 2 cosine to the 4th x. Well, our 1's will go away, right? So I'm left with 2 cosine squared x over 2 cosine to the 4th x. Our 2's will go away. So I'm left with cosine squared x over cosine to the 4th x. Well, that can be reduced, right? So that's 1 over cosine squared x reduced by cosine x squared x's. 1 over cosine squared x is secant squared x. And secant squared x is 1 plus tan squared x. Another trig identity. Then there are formulas for lowering powers. They go from squareds down to double angles, which are those three right there. Using those three. Sine squared, they wanted the first powers of cosine, so sine squared x changes to 1 minus cosine 2x all over 2. And cosine squared x changes to 1 plus cosine 2x all over 2. Now we now have two fractions multiplying each other. I'm actually going to factor out the denominators so I don't have to worry about them. So I'm going to factor out a fourth, because 1/2 times 1/2 is a fourth. And the numerators are technically a difference of two perfect squares. Same things in your bubbles, 1 plus, 1 minus. So that becomes 1 minus cosine squared 2x. 1 minus cosine, they want it in the first power of cosine. So I have to take that cosine squared and reduce it again. So leave my 1/4, leave my 1. And this will now change to 1 plus cosine 2 times 2x, because our angle is actually 2x, all over 2. Well, if our denominator is 2, I'm going to change this 1 to a 2 over a 2. So I have 1/4 up front. 2 minus 1 is 1. And then minus a cosine, so minus cosine 4x all over 2. And either multiply in the fourth or factor out the half. 1/8, 1 minus cosine 4x. Or if you have 1 minus cosine 4x all over 8, that is fine as well. Half angle formulas. Here are half angle formulas. Notice that in the actual function, they use basically double of whatever they're asking about. So in this first one, if we're asking about 22.5, the actual u, you double it and it's 45. So 45 is actually what we're using when we put into the function. And 22.5 is in quad 1, so it's going to be a positive version. So this will be the square root of 1 plus cosine 45 all over 2. Cosine 45 is the square root 2 over 2. So 1 plus radical 2 over 2 all over 2. Again, I will change my 1 to a 2 over 2. And this will become 2 plus radical 2 all over 2. And I'm going to flip this one, so times 1/2. Last piece. Oops, that's the square root. We get 2 plus radical 2 on the top. Well, the bottom of the fraction, if you multiply 2 times 2, you get 4. The square root of 4 is 2, so that comes out. comes out of the square root. Square root just on top, no square root on the bottom. And this next one, they want to find tan u if sine u is 4/7. So we need to draw a right triangle again. That's our u. Sine is opposite over hypotenuse. Using Pythagorean theorem, the third side is the square root of 33. We are in quad 2, which means tan will be negative. Negative. 1 minus cosine u over sine u, or sine u over 1 plus cosine u. It doesn't really matter. We can use whichever one we want to use. We'll use sine u over 1 plus cosine u. So sine u is 4/7 on top. And on the bottom would be 1 plus radical 33 over 7. Are we good? So this changes to 7 over 7. I feel like there's an easier way to do this, but that's okay. 7's all in the denominator, which means they go away. So we're left with really 4 over 7 plus radical 33. Well, we can't do that, so we need to multiply 7. I have to hurry up because the bell's going to ring. So fix it. Fix this so it's not a square root in the bottom. So rationalize the denominator. Rationalize. Don't leave it. But I'm going to skip on to save time. So if we're doing product to sum formulas, you literally just have to match up. So sine, 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 sine. All you have to do is fit in the pieces. 2x is equal to our u. 4x is equal to the v. Oops. So I have 1/2. Oh, let me get that formula back up. Cosine of 2x minus 4x minus cosine 2x plus 4x. So 1/2. Cosine 2x minus 4x is negative 2x, but cosine of a negative angle is its positive version, so this is 2x. 2x plus 4x is 6x. And we are done. Sine cosine, we just have to match it up with the one that's up here. So this is u, v. So we have 1/2 sine u plus v, so 15 plus 15 is 30, plus, and then 15 minus 15 is 0. Well, we can keep going, right? There's no x's, so we can actually keep going. So 1/2 plus 0, this is 1/4. Going the other way, product to, or sum to product, sine plus sine is up here. So this is our x, that's our y. So 2 sine 11x plus 5x all over 2, and cosine 11x minus 5x all over 2. 11x, 5x is 16x divided by 2 is 8x, so 2 sine 8x, 11x minus 5x is 4x, 4x divided by 2 is 2x. It is not, this is 6x. 6 divided by 2 is 3. 3x. 3x. All right. And there's the bell. So work on this one in class. That's what you could do. You could try to work on that one in class. That'd be a good brainstorming activity.